How's everyone doing? It is time for Kahoot. Who all do we have in the chat? We're moving around the lights right now, getting everything nice and perfect in here. So with that, let's go over here to the main screen and let's start Kahooting. Oh my gosh, Emma, good to see you there. Good to see you there. Savannah and Daniel. Who else we got in the chat right here? Savannah, Daniel, Ella, Pedro. We got Marley in the chat and Rachel. Good to see you here, everybody. Let's turn up that music. Where's our Kahoot music? We don't want the original. We want the disco. We're always going disco here. There we go. I think I knocked my AirPod out yesterday and I broke the right AirPod. It's not going and it's driving me crazy. Good morning, Joe. Good to see you there. Let's throw out 1,000 mute points. So here we go. I'm Layla. Oh, that's no. Hey, Space Cat. Good to see you there. Switch between accounts if you want. I can merge at the end of the semester. Let me know if you have different accounts. Got a literal Space Cat in the chat. I know, right? It's like not going. It's either not charged or not going. But I'm not hearing anything out of my right. There's writing on here. Writing on the AirPod. I didn't know that. Good morning, Skylar. Good to see you there. Join on in. How many people we got watching? That's driving me crazy that the right AirPod's not working. Driving me crazy. Oh my gosh, we have a total of how many people watching live right now? We'll wait here just a minute or two more. What is the website to join again? You just scan that code up there. Just hold your phone out. You can go to kahoot.it and enter that in, or you can just hold your phone up to the screen right there. Just bring your phone. Did anyone do that right there? Say yes in the chat if you held your phone up to the screen and just scan that QR code at the top. Good morning, Kate. Good to see you there. So that should just bring you there. If you just go over it. There's also an app now, yeah. So you can hover over that. There's the app. Really good stuff, Kahoot. We really like it. Got it? Nice. We'll get started here in about 2 minutes. So one thing I want to point out right here, and I sent this in an announcement, is that the assignments are going to be more difficult for the remainder of the semester. But the biggest thing, Daniel's locked in right there, is you want to start early on the assignments. Starting early is the key. If you start early, you can ask questions when you're stuck. Because if you don't know how to do these last few assignments, you're just like, what am I even doing? So don't worry about getting stuck. Realize that you will, because the material is going to get more difficult, and then just be ready to ask us for help. Does that make sense? Like when it gets tough, don't worry. A lot of people are going to think it's tough. A lot of people are going to get stuck. A lot of people are going to be like, how do I do this? And they just ask. Just be like, how do I do this question? Problem is if you wait till like 10 or 11 at night, then you're like, how do I do any of this? And then you don't know. It's very difficult. Like there's less material though. That's the good part. The office hours saved you, Joe. I like that right there. Especially we walk through do we basically do every question in office hours, Joe? Do we do basically every question? I mean, I almost think literally every question. I think we did every homework question for chapter 14, and we did pretty much every, and I did it multiple times too. I don't know if I missed any, but I'd say we did pretty much every question. So Emma right there saying also office hours saved her right there. So I try to do all of them. I try to explain them thoroughly. I try to go through the examples. So you're going to see me do a full walkthrough of it. So kind of watch the office hours and hone in on it and be like, okay, so what's he explaining right here? See if you can answer the question for me. Thank you, Lauren, right there. Yeah, that's what I try to do. I try to make it, it's tough because I'm like, I have to go into detail, but I have to answer the question. But I want you to understand the theory behind the question. So I don't want to do it too quickly and then it's like, oh, here's the answers. And then you just plug in numbers. But that's a lot of what it is. It's just like find the numbers, plug in the numbers. I have until 11:30. We're welcoming some students here today. So this will probably be about 70 minutes. It is recorded if you have to leave. And we're gonna get started here in 30 seconds. So 30 seconds now, let me put on a 30-second timer. 30 seconds, 30 seconds, 30 seconds, 30 seconds, 30 seconds. So with that, 30 seconds to go. Anyone got any big plans for the weekend? Big plans, big weekend plans? Well, thank you, Rachel, right there. I appreciate that. It's math is a thing I actually like. I'm one of those weird people who likes math. Like if you're like, I hate math, going to Nashville. Nashville's really cool. There was a restaurant called Cork and Cow in Nashville. I don't know if it still exists. We had a really good steak. Studying. Take a break from studying too. Study, have a good time. Mowing grass. Actually, I might mow some grass too. Might mow grass for the first time on our lawn. First time mowing grass. It's just my hair does that thing up front. I got see, that's not, I don't know. Keep looking at my hair. Peyton's getting older. Study and play some Mass Effect. Which Mass Effect? We'll end with that, Joe. Which Mass Effect? Mass Effect 1, 2, 3, Andromeda. I started playing Mass Effect 1 and then just didn't finish it. It's good. Big games, Mass Effect. But I didn't finish it. I might play some Isaac, something. Same, had to keep the grass long for Easter. Beach, going to the beach. Nice. Second is the best. I'll have to try that out. Well, you know what time it is? I need some I'm readies in the chat because we're about to start right here. We've passed the 30 seconds. Give me some I'm readies because we're getting started. And if you haven't clicked it, get your phone ready because we're starting here. So I need some I'm readies in the chat. Some I'm ready, I'm ready, I'm ready. That's how we start our Kahoots. Ready, here we go. I'm ready. Time to Kahoot. Remember, have your notes out beside you. Have a formula sheet out beside you because the first few questions I think are straight from the formula sheet. So be looking at the formula sheet. Two events that can be easily added together must be what? Two events that can be easily added together must be what? Now, as I just said right here, we are talking about something that is on the formula sheet. So if you get this wrong, don't worry. And there are two answers to this. We're going to go to the formula sheet, which is the pinned link here. So if you are doing the Kahoot right now, I asked this, or watching this in the future, print the formula sheet out now because you're going to need it for the test. But why wait for the test? Print it out now and study with the formula sheet. Now you can take notes on it, but you need a clean formula sheet for the test. But questions like this are actually on the formula sheet. So if you have the formula sheet beside you, you should get this right no matter what. There are technically two answers. Does anyone want to put the two answers in the chat for practice? Two events that can be easily added together must be what? Two events that can be easily added together must be what? Pretty good job, but notice we do have 12 wrong answers. That's all right. Let's take a look right here at the formula sheet. So disjoint and mutually exclusive are the same thing. So notice we're going here to the link that's pinned by Mubot, and we have right here the formula sheet. And take a look right here where it says the probability of A or B, they must be mutually exclusive. Does everyone see this? So if you have the formula sheet beside you, what is the probability you should get this question correct? Which all probabilities are contained between 0 and 1. Well, if you have this beside you, what is the probability you get this correct? So explain why independent is wrong. Independent means knowing one thing does not influence the probability of the other. So when we add together events, they need to be disjoint, but when we multiply, they need to be independent, because that means the probability of one thing would not be influenced by the probability of another. Like take, for example, let's say the events of it's snowing today and it being 110 degrees today. Now, can both those things happen at the same time? We'll go over here to a Word document. Can it snow and be 110 degrees today? Can it snow and be 110 degrees today? Can it snow and be 110 degrees today? So here's the probability of snow today on a random day in Knoxville. And here's the probability of 110 degree weather. So in Knox, that's silly, right? They can't happen at the same time. Disjoint means if one happens, the other can't happen. That's the way to test disjoint. If it is snowing, it is not 110 degrees. Those are disjoint. They do not have any parts that overlap. They are mutually exclusive. They do not include each other. So what is the probability of it snowing or being 110 degrees? What is the probability of it snowing or being 110 degrees? So we've got the work right here where we just plug in the numbers. So try solving this along with me. What is the probability it snows or is 110 degrees according to this data right here? What is the probability it snows or is 110 degrees? 0.02, we just add them together. Because they are disjoint, they have no overlap, so we can just easily add them together. Now here's the problem. How does independent and dependent play into this? Now this is an advanced thing, kind of tune out for a moment if you don't want to hear the advanced ideas. These two things, these two probabilities are very, very what of each other? Independent or dependent? These two probabilities are very, very independent or dependent. For this example, they are very, very independent or dependent. Now this is a little advanced because I'm not doing exactly what the rules say. They're very dependent, that is correct, because snow would depend on the temperature. So technically, and this is a advanced note, disjoint events are dependent. But that's not when we add things together, and we don't add together dependent events. The disjoint events are dependent because if one happens, the other can't. Does everyone see the overlap? This is a little advanced, but it's the idea that disjoint events let you know if one happens, the other can't. And the idea of independent is if one happens, it does not give you information about the other. We're kind of going a little advanced on how the topics overlap. Does that make sense? But the most basic sense of this, that if you're just trying to memorize for the test, which I do suggest, is that if you want to add together two events, they need to be what? Repeat this again and look at the formula sheet. They are the same, they're synonymous right there, Space Cat, great job. And so if you want to add together two things easily, the rule is that they must be that, mutually exclusive, which is disjoint. It's literally the same word. It's like saying I'm tall and I have a lot of height. I don't know, like it's the same thing. You're like, you're tall, you have a lot of height, you're just repeating yourself. By saying mutually exclusive, we're saying disjoint. They're the same word. Like if we say something tastes good or it has a nice taste, we're saying the same thing, but just using a different word. So disjoint is mutually exclusive. It's just a different word for it. So good work right there. Let's head back to the Kahoot right here. Who is in the lead right here? We got Agent Boa, Glowing Macaw, Mountain Octopus, Friendly Panda, good to see you here, and Elated Goose. Next question, two events that have no influence on the probability of each other are said to be what? Two events that have no influence on the probability of each other are said to be what? Two events that have no influence on the probability of each other are said to be what? And I really miss the animations. I'm gonna see if I can get animations back. I don't know what it is. No questions and answers, true. Characters. Where's the animation thing? Autoplay is off. It's on this computer, it doesn't do animations. I do not, wow. Oh my gosh, where's my real wow?
Wow.
Owen Wilson's even impressed, really good job. I don't know why I don't have animations anymore. Margin of error essentially means things can happen. Oh, mutually exclusive. So mutually correct. Brooklyn, great answer right there. Mutually exclusive means that if one thing happens, the other thing can't. My favorite example of that is if your parents bring you to the pet store and they're saying, you're getting a dog or a cat. What are your parents telling you? When it comes to mutually exclusive, which is also disjoint, if your parents say you're getting a dog or a cat, think about the way they're saying that. They're kind of telling you it's mutually exclusive. So what does that mean when your parents say you're getting a dog or a cat? You're not getting both. So now you could say, hey, is this a, is this a not mutually exclusive thing? And they say, no, this is mutually exclusive. It's disjoint. Disjoint, the way I like to think about disjoint visually is if you think about dog or cat, you would have disjoint is when dog and cat have no overlap, but jointed is when dog and cat, like a Venn diagram, has an overlap. So this is not disjoint, mutually inclusive. This is disjoint when one occurs, the other can't occur. Does that make sense that this is disjoint up here? This is not disjoint where there's an overlap. So if your parents are like, yeah, you can get both, you say, oh, it's not disjoint. It has an overlap, it has a joint to it. So think about what the words mean, like how the concept of disjoint means they're disconnected and not disjoint means they have a connection. And that is disjoint, that is not disjoint, that is mutually exclusive, this is not mutually exclusive. Oh, Marley, no, you can still log back in. And the idea of independent right here means if you know one thing happens, we'll have the code back up here in a second, Marley. Independent means knowing one thing happens tells you nothing about the other. So I always like to use the example here of Brian drinking coffee. So Brian drank coffee today. Darren, his brother, drank coffee at the time. Darren drinks coffee also 90% of the time. And tell me, why can't you just add together all these probabilities to find the probability Brian or Darren or Chelsea drinks coffee? Why can't you just add together these probabilities to find out the probability Brian drinks coffee or Darren drinks coffee or Chelsea drinks coffee? And in truth, if you did start to add them, it would start to look something like this right here. So you'd have this sort of mess right here. That's what it would start to look like. So explain to me why you can't just add them to find the probability Brian or Darren or Chelsea drinks coffee. A little bit of review right here with the concepts and what they mean. I want you to think about like, okay, what does these concepts mean? Why can't I just add those probabilities? What does that mean? Why can't we just add them? Well, first off, if you add them, you'll see the problem. 90% plus 90% plus 90% is 270%, which immediately breaks the rules of probability. Any thoughts on this? You can't add them easily together because they are not what? They are not mutually exclusive. So you can't easily add them together because they're not mutually exclusive. But two of these are probably independent. Which two people drinking coffee are probably independent of each other? Which two people drinking coffee, or there's probably two sets of individuals. So which two sets of individuals, or which two people you can name, are probably independent of each other? Brian, I would actually say it's probably Brian and Darren are independent, because knowing, and Brian, Chelsea and Darren too, probably. Brian and Darren are probably independent because Brian drinking coffee does not influence Darren drinking coffee. But since Chelsea and I share a coffee maker, Brian and Chelsea might have dependent probabilities. If you found out Brian drank coffee, you would think it's probably what that Chelsea drank coffee. Let's say Brian did not drink coffee. You'd probably think it's what likely Chelsea drank coffee now. If you find out Brian did not drink coffee this morning, it would influence your change on Chelsea, your probability. You think it might be less likely. How are it being 101 degrees and snowing in Knoxville mutually exclusive? Let's review that one again right here. Good answers on this. So snow in Knoxville and 101 degrees in Knoxville. Why is this mutually exclusive? And the answer is, try answering this in the chat. So why is this mutually exclusive? The answer is because this, what am I explaining to you? Why is this mutually exclusive? So why is this mutually exclusive? It can't happen at the same time. It can't snow and be 101 degrees. If it's snowing, it's not 101 degrees. If it's 101 degrees, it's not snowing. They can't happen at the same time. That's what mutually exclusive means. Why are these dependent? So you have to ask, if I know it's snowing, does that tell me anything about it being 101 degrees? So that's the way to ask dependent, is if it is snowing, does it tell me anything about it being 101 degrees currently right now? And so with it snowing, it gives you information about the temperature, so you know, does this make sense on dependent down here? The way to test this is, if it is snowing, does it tell me anything about the temperature outside? And the answer is yes, so they're dependent. So why are these independent? The answer is no, because we get information about the temperature when it is snowing. So the temperature is not independent of it snowing. Does that make sense? Thank you, Bailey, right there. And really good questions. These trip people up. Try writing your own examples and try doing multiple practices like this, where you ask your questions of, are these mutually exclusive? Are these independent? Are questions on the test? Just like this. Let's head back to the Kahoot. These are big questions. There are questions that go over, is this independent? Is this mutually exclusive? Here we go with the leaderboard. Let's check it out. Mountain Octopus, Legend Gazelle, Jolly Boa, Helpful Stork, and Glowing Macaw. Next question. Snow is cold, so yes. Multiply the probability of A and B. Two events must be what? Remember, formula sheet, formula sheet, formula sheet, formula sheet. And we've been showing this. We won't spend too long on this one because I have to be done by about 11:20 at the latest. But we're going to go to the formula sheet again and see that the answer is on the formula sheet. The Kahoot code is right below if you have to rejoin. The answer to this is on the formula sheet. Who looked at their formula sheet? Type yes in the chat. The answer to this is on the formula sheet. Don't worry if you got it wrong. There's the answer right there. The answer is independent. Did anyone go here and look? Savannah did at the formula sheet. That's the test right there. We don't want that. So we go back and we go here to the formula sheet. Notice that the rule to multiply two things together is independent. So make sure while doing this to look at the formula sheet. Pretend this is the test right now. Have the formula sheet beside you. I'll tell you this much. At the end of the Kahoot, we will be using this formula, I think, for the last question. So a hint for the end of the Kahoot, you will use the standard deviation of p hat for the last question. So it will help to have your formula sheet beside you. But the rule for multiplying two things is that they are independent. Knowing one tells you nothing about the other. The multiplication rule, the probability of A and B, is that they have to be independent. Have your formula sheet beside you and ask questions in the chat. Let's look at that leaderboard. Jolly Boa, great job, Helpful Stork, and Legend Gazelle. Let's keep going. Next question. The probability of a gross jelly bean, one you don't want to eat, is 25%. If you eat 3 jelly beans, what's the probability they're all good? So if you don't know how to solve this, listen in. The first one, yes, you can have it right beside you. No notes on it. Great job, Rachel. So what is the probability of a good jelly bean? If a gross jelly bean has a 25% probability, what's the probability of a good one? So if you're stuck, work along with me right now. So a gross jelly bean is 25%. What's the probability of a good one? Feel free to type it in the chat. 75%, and that's the complement. It's either gross or not gross. We'll call that good. So a good jelly bean is 75%. Pretend you're eating the jelly beans. First jelly bean was good. Second jelly bean was good. And third jelly bean was good. Now think about this sentence. First was good, and second was good, and third was good. What do you notice right here? Oh no, it's Snowy Space Cat. Does anyone start to see it? First was good, and second was good. Do you think each jelly bean cares about the previous one? When you eat a jelly bean, the next jelly bean's like, I'm gonna change my probability of being good. Each jelly bean is what of the other jelly beans being good? Emma knows right there. Each jelly bean is what of other jelly beans being good? Each jelly bean is what of other jelly beans being good? Independent, which means we can multiply. And we said good and good and good. And if you look in the chat right now, you'll see 75 times 75 times 75, which means the answer to this question is right there. It was 0.75 to the third power right there. 0.75 to the third power. Did everyone follow along on those steps? I'm gonna write it out here real briefly, but we kind of talked through it there in those 90 seconds, where we want to find the probability of good is equal to 75%, because the probability of bad, great job on the independent right there, is equal to 25%. And we want to find out 3 good jelly beans in a row. So it's good and good and good, which is 0.75 times 0.75. We meet the rule of independence because knowing one jelly bean was good tells you what about the next jelly bean being good. Like you reach into a bag of jelly beans that come from a manufacturer where 75% are the good kind, and you just grab a random one and you eat it. Knowing that that jelly bean was good would tell you what? We're talking very large sample right here. It's not like it's changing probabilities. Knowing that that jelly bean was good tells you what? And Rachel's kind of said right there in the chat too, it tells you nothing, they're independent. And I was looking for the word nothing. They're independent because knowing one jelly bean is good tells you nothing about the next jelly bean. You're not gonna be like, oh, that last jelly bean was good, I bet this next one will be good. You know 75% are good. Knowing that the last one was good doesn't tell you if the next one is good or bad. It gives you no information. That each jelly bean is independent of the previous one. And since they are independent, we can multiply the probabilities. So that is how we multiply and check the formula sheet. Knowing we can multiply properly is done by checking if the two things, the first jelly bean and the second jelly bean, have independent probabilities, and they do. So really good question right there. Another one coming up, a little tougher. I think it's an at least one problem. Grab a sheet of paper if you don't have it. Get ready for an at least one problem after the leaderboard. Legend Gazelle, Helpful Stork, and Friendly Panda. Legend Gazelle jumped into the lead. Here we go, next question. Multiple choice questions have an 80% probability of getting correct. After studying with 5 questions, what's the probability you get at least one wrong? 90 seconds to go with an at least one problem. Work through it here with me if you're stuck. So if you get at least one wrong, you could get 1 wrong, you could get 2 wrong, you could get 3 wrong, you could get 4 wrong, you could get 5 wrong. But what would not happen if you got at least 1 wrong? If you got at least 1 wrong, what didn't happen? You could get 1 wrong, 2 wrong, 3 wrong, 4 wrong, 5 wrong out of 5 questions. What didn't happen? Getting them all right. So you'll either get them all right or get them all wrong. What's the probability you get the first right and the second right and the third right and the fourth right and the fifth right? So you get everything right. What's the probability of getting the first right and the second right and the third right and the fourth right and the fifth right? What's the probability of that? First right and second right and third right. And take a guess if you don't know, if you're super duper stuck. What's the probability of getting every question right? First right and second right and third right and fourth right and fifth right. 0.8 to the 5th power. So you'll either get them all right or you won't get them all right. So how could we find the complement of getting them all right? Savannah, you'll have the answer once you do that. Because either you will get them all right or you won't get them all right, which means at least 1 wrong. So what is the complement of that? Which that's the answer. And the complement is always 1 minus whatever we found. Savannah, yes, Savannah, great job. Savannah has the answer. And really, we got a lot of great answers right there. And so let's show this out visually here. Good work. Now, the way to solve an at least one problem is to write your sentence. What is the probability of getting at least one wrong? And the probability of right is equal to 80%. The probability of wrong is equal to 20%. So when you do this right here, you have that you will either get at least one wrong, or, and I'll write or right here, what? And just repeat it. This is practice, remember, even if you know it, it's just helping hammer it down. You'll get at least one wrong. You'll get either one wrong or two wrong or three wrong or four wrong or five wrong, or you'll get them what? None wrong, none wrong, none wrong. And none wrong is the same thing as all correct. All right. Does that make sense? None wrong is the same thing as saying all right. Because either you get none wrong means you got them all correct. And I'm going to change this or here to addition because these are disjoint. You can't get one question wrong and all questions right. You can't get two questions wrong and all questions right. These are disjoint, and it's everything that can occur, so it adds to one. Because you're either going to get at least one wrong or you'll get them all right. Does everyone follow on this logic? Like writing this sentence is the key to solving these. If you can start writing these sentences like I do right here, it'll start to make sense what you're trying to find. So now all we do is, since we want to find at least one wrong, we just algebra this over to the other side. I want a testimonial from a student in the chat right now. Have you been using this methodology that I have right here to solve these questions and it's helped? Or you can say no. If no one says yes, then I'm going to be like really sad, but don't just say yes. Probability of getting them all correct is 0.8 to the fifth power. I truly think this helps. You get better and better at it by doing this right here and kind of logically thinking through and writing your sentences. And then there's the answer. The answer is 1 minus 0.85 to the fifth power. And we'll just type that in here now. I'm going to knock over more things. 0.8 to the fifth power. So 2, 3, 4, 5. And then 1 minus. There we go right there. So the reason 0.8 to the fifth power is getting them all correct is because getting everything right is going to be right and right and right and right and right, which translates to 0.5 times 0.5 times 0.5 times 0.5 times 0.5 right there. So that is the probability of getting everything correct right there. And that translates into this. When we talk about it, I got the first right and the second right and the third right and the fourth right and the fifth right. So we go right there, and that is the probability there, and we're doing 1 minus it. So, and that is the probability of at least one wrong. Oh my gosh, Savannah, we're throwing out 1,000 points right here. I don't know, I was thinking heads and tails flips right there. Savannah correcting me right there, that is correct. And how did I enter into the calculator? I think I was thinking 5 times, so I just started typing that. Savannah with the correction, we like that here. Thank you, Savannah. What did I do? I think I did it correct in the calculator, right? 2, 3, 4, 5. Yeah, I did right in the calculator. There we go. Yep, thank you so much, and good W. Big points in the chat for the students right there. Make sure to, whenever you see errors, let me know. I do make them every once in a while. You never know. W's in the chat. Oh man, even Mubot got to throw some W's in there. Mubot, where you at with some W's? Let's head back over here. Mubot's gonna type away. W's, Mubot. Oh, thank you, Mubot, being supportive in the chat right there. So let's head back over to the Kahoot and do the leaderboard. Here we go. Helpful Stork, Legend Gazelle, Stellar Tiger. Great work. Next question. What is the first thing we need to do when doing a sampling distribution? And the answer is not notation. The first thing you should do, not notation, because before doing notation, you need to identify what? It's not notation, not p-values. When doing a sampling distribution problem, which is the chapters we've just been covering, these are the tough ones. My students will know right here, sorry if you're in another class, but I remind people all the time, Kahoot's partly for fun, partially for prizes, is figure out if it's cat or quant. I'm so happy this is a commonly missed question, but I want to point out why we need to figure out if it's cat or quant. Because the formulas depend on if we're doing categorical or quantitative data. Daniel knows right there. Great job, Daniel, with that cat or quant in the chat. So we need to know if we're doing proportions, which is categorical. So imagine I say to you, we are trying to figure out, or we want to look at the GPA of UT students. And Savannah knows right there. Would that be from the registrar? Are we looking at the distribution of sample means or the distribution of sample proportions? We want to look at GPAs of students. Oh, there goes Savannah. So would we, with GPAs of students, would we be looking at sample means or sample proportions? GPAs of students. The GPAs of students. It'd be the distribution of sample means, because GPA is a quantitative measurement. How about if we want to look at how much students spend on Taco Bell a semester? How about we want to look at how much do students spend on Taco Bell a semester? Is that means or proportions, which is quant or cat? Savannah might be answering the second one because great job. That'd also be means. And if we want to look at do students love Taco Bell, yes or no, that'd be the proportion of students who love Taco Bell, because that's categorical. I miss me some Taco Bell. So proportions is always a categorical thing, like a yes, no, that puts people into groups, where means is always a quantitative thing, like how much money or what is your GPA or how tall are you. Those would be means. Proportions put things into groups. Leaderboard time, Helpful Stork, Legend Gazelle, Stellar Tiger, Rockstar Bad, and Genius Puffin. You look like a unicorn over there. Next question, let's do this. When trying jelly beans, if you take 2 jelly beans, what is the sample space of good and bad jelly beans? I think this is a pretty easy test question when this appears, but you have to think of all possible permutations of which they can be good and bad, including the order. Including the order. This includes the order. I think that usually gets people all missing on that. But it does include the order by which good and bad jelly beans can occur. It would include the order, something important to consider right there. So what would it be? Really good work right there. It'd be, you could get a bad, a bad, a good, a bad, a bad, a good, a good, a good. Now, what is a sample space? Have a definition on a note card right now. The sample space is what? What is a sample space? Have your note cards out or write it in the chat. If you see someone write it down with them. The sample space, and that is the sample space down there. All possible outcomes, exactly. You're just saying, so what's all possible outcomes? Be careful, because that's Savannah. Good answer, Savannah, right there. What is a sample frame? So what is a sample frame now? This is a sample space of possible combinations of outcomes of selecting jelly beans. What is a sample frame? Sample space is the chapter 12 concept. Sample frame is the chapter 10 concept. It is what the individuals from which we can select our sample. Great job, Savannah. Multiple practice right there. So the sample frame is kind of a frame by which we draw out our sample from, the individuals we could possibly select. Where the sample space is the possible outcomes when doing outcomes of sampling things. It's the possible outcomes, the sample space right there. All possibilities that could occur is the sample space, and then the sample frame are the possible individuals we could select when taking like a simple random sample or a cluster sample. So be very careful. Chapter 10 and 12 have a very similar term, sample frame, chapter 10, the possible individuals we could sample, sample space, chapter 12, the list of all possible outcomes. Let's check out that leaderboard. Legend Gazelle, Stellar Tiger, Helpful Stork, Inspired Urchin, and Glowing Macaw. Next question. What 3 values will you have to write interpretations for on test number 2? You're gonna have to write the interpretations here. So you probably haven't heard of some of these, that's all right. RMSE is root mean squared error. I haven't told you about that. Standard error, we have talked a little bit about that. That's an estimate of the standard deviation. VIF is variance inflation. I'm not gonna talk about that right now. R squared is the percent of variation Y explained by the variation X. Slope is for each one unit increase, we expect Y to increase or decrease by B1 on average. Intercept is when X is equal to 0, we expect Y to equal B0. And we need to say if it's logical. QQ straight enough, no outliers, plot doesn't thicken, are the conditions for regression. Multiplication, addition, and complement are the probability stuff. And so people generally got this. I'm going to do one of these right now to see if you can do it. Great job, Lauren. Is a frame all possible outcomes from the... no, the sample frame is the possible individuals we can sample, Lauren. Buster Rhymes right there. He's a good artist. The sample frame is the possible individuals we could sample. Like if you hang outside the library and talk to people, your sample frame would be people outside the library. So if you hang outside the library and talk to people, your sample frame, the possible individuals you could speak to are people outside the library. That would be your sample frame, like the people you could. And Lauren, thank you for asking. Please ask those questions. So Brian is currently making a what? Brian is currently QQ, making a what right here in the background? Oh, wow. That has an issue. Brian is currently making a what? What is this? Whew, that's got a lot of issues. Scatter plot with a regression right here. This is a regression. Now the linear equation is seen right here. This is the linear equation for the scatter plot. And the quantities we have right here are what? What is the notation for these quantities? As in, what is, I'm going to highlight them right here. What is this quantity? We're going to put a little hat over it. What is this quantity? What is this quantity? What is this quantity? Good job. This is the predicted attack. What else do we have? We don't have everything marked yet. This is going back to regression, which we haven't done in a while. This is regression, you got it. What else is on the screen? What are those other quantities? Great job, Joe, right there. B0 plus B1x. So when you do these and you write your interpretations, when x is equal to 0, we expect y to equal b0 on average. Is this logical? For each 1 unit increase in x, we expect y to increase / decrease by b1 on average. Blank percent of the variation in y is explained by the variation in x. So with this right here, these are the interpretations for what? Tell me in order what these are the interpretations for. Tell me in order what these are the interpretations for. Like the first, the second, the third. I've just written multiple interpretations. And I'm going to fill them in for you. What are these the interpretations for? So let's highlight the green is the y variable right there. That's where that would go. The x variable defense would go in here and goes there. We have to select one of these. Pick one based on the sign of the coefficient, which would be this right here. So, and then B1, that is over here. Please tell me if I make any errors. I can make errors while highlighting stuff. And then B0 is over here. And people are saying in the chat that right there, that is the intercept known as B0. So this is the intercept. Oh no. This is B0. Shouldn't have highlighted things first. This is B1, which is the slope. And this is going to be R squared, which is the percent of variation in y explained by the variation in x. So there we go with the things right there. B1 is the slope and B0 is the intercept. And I think I have pretty much everything right here figured out. But here's the thing. Can you interpret these? Right now, except for R squared, which is not on the screen, could people write out any of these interpretations? And I beg this of you, try doing it. I can do it, but that's because I've done it a bunch of times. You don't get a cheat sheet like this on the test. Try writing any of these out. And let's say the R squared is equal to 0.45. So there's the R squared. When defense is equal to 0, great job. We expect attack to equal 45 on average, but I don't know about Pokemon, so I don't know if defense. Great job, Joe. Perfect answer. And we wouldn't put that on the test because we don't expect you to know Pokemon. So we'd ask something like height, weight, age, or something like that people would know. Try another one right here. Try another one with the information on the screen. Everything can be interpreted now that I gave you an R squared value. R squared value for this is actually right here. It's 19.2. Well, I changed it. Did I just delete it? Pokemon is anime, right? It is. Japanese animation is anime. Pokemon is anime. That is a fact. You can still call it 45 if you already wrote that. Try doing another one. The only way to do these is to practice them. The only way to know these is to be able to practice them. People get to the test and they're like, I have no idea what to write. They say, I don't know. I got no idea. For each 1 unit increase in defense, we expect attack to increase by 0.45 on average. Savannah, perfect answer. Perfect answer. Perfect. Just filling in the blanks. For each 1 unit increase of defense, we expect attack to increase by 0.1 on average. Let's try the R squared right here. That's the last one to do. R squared is always multiplied by 100 when it's given in its base form. 19.2% of the variation in attack is explained by the variation in defense. Perfect. Joe, Savannah right there, everyone practicing 1,000 points. Where you get these points if you're here talking. So make sure to just say something because then you get the points. But the only way to do this is to practice these. If you get to the test and you haven't been writing them out, you look at these questions, you say, I got no idea what to write. I haven't been practicing that. And that's all right. Ellie, great job right there too. Notice that it's just plug and chug. Take a screenshot of this if you need. And we're going to have some more right here because we do have 2 more reviews of these coming up in a moment. Let's take a look. Leaderboard, Legend Gazelle, Stellar Tiger, Helpful Stork, Inspired Urchin, and Glowing Macaw. Next question. Let's do this something. What is the interpretation of the slope? Be quick to click because you get it right if you click. But go ahead and click as fast as you can. I think I have the right thing clicked. Please tell me I didn't have an error in this. But with this, someone typed in the blank interpretation in the chat. I need at least 3 people to write the blank interpretation of the slope. Just the blank interpretation of it. It was too long for me to put here. I want you to type it in the chat. 3 people for us to move on to the next question. If you're at home, write it down, say it out loud. Everyone clicked in the right spot. I pray I didn't put a click here in the wrong spot, but because the next one's gonna be the same thing. But someone write the interpretation of the slope in the chat as a blanket interpretation. For each 1 unit increase in X, we expect Y to increase or decrease by B1 on average, and you'll select one of those. Great job right there. You don't say both. I've had people write increase size decrease. I'm like, no, you should pick one based on the sign of the slope. And thank you right there, Ellie, Joe, Catherine, people practicing. This makes my day because I mean it. People get to the test and then they leave these blank and I'm like, well, there's 4 points on the table that you didn't get. I want people to get good grades. I want you to know what's on the test. There are 3 interpretations on the test worth 4 points each. Next question coming up. It's gonna be another easy one. Legend Gazelle, Stellar Tiger, Helpful Stork. Here we go with the next question. Let's do it. It's gonna be another easy one. What is the interpretation of the intercept? Get ready to click. I've got like 30 more minutes, so I gotta make sure I'm on time. Really quick right here. People clicking away. Now go ahead and type the interpretation of the intercept. I'll even say it to help you out because so many people wrote it out that I've got faith that you're gonna say it, write it too. Wow, we got people clicking away. So the intercept is, write it with me right here. When X is equal to 0, we expect Y to equal B0 on average. Savannah already just with it right there, and Ellie. When X is equal to 0, we expect Y to be B0 on average. Low tapper fade. Right. Thank you, Roto, right there. You like it? Is it good? Is it good? Is it good? I went crazy and did it, Roto. Roto, so good to see you here. Let's throw 1,000 points for a Stat201 Hall of Famer, RotoWave. Give some W's. You know what? We're gonna go crazy and give 2,000 for RotoWave. Throw some W's for RotoWave. So say hey when you see me around campus. You're still around, right? But say hey if you see me around campus, RotoWave. I hope if you've graduated, awesome. If you're still around, say hey. But with this leaderboard, Legend Gazelle, Stellar Tiger, Helpful Stork, and Inspired Urchin, Glowing Macaw. Yes, well, graduate too. I want you to graduate, but I also want to say hey to you. Next question, let's do this. We decide to talk to students in dorms and talk to all students who live in Brown as a sample. What kind of sample is this? Now there's a key thing that was done right here. Oh, does Pedro know RotoWave? There's a key thing that was done here. A key thing. Does anyone see the key word that makes you know what this is? There's a key word and a key thing. They're hanging out in the chat. What's the key thing? The answer, cluster. Pretty good, pretty good. I'm actually happy that stratified wasn't as high. Why is it cluster? When you do clusters, you always do a what on the cluster. Think of a C word, which this is basically that up there. When you have clusters, the all, right, Brooklyn? You do a census of the group. So things are put into groups and they do a census on the group. Where in stratified, you acknowledge differences and then sample according to those differences. So there's always a difference acknowledged, like let's take 20 students from each dorm. Usually see like 20 from this, 20 from that, 20 from this. That's stratifying to acknowledge differences and take in accordance to those differences. Systematic sample is every kth observation, and simple random sample is going to be giving every student a number and selecting the students randomly. Multi-stage is combining them together. There's not a lot of chapter 10 in this review. This is the only question. So chapter 10 is a very note card chapter with voluntary bias, with response bias, non-response bias, all the types of bias or undercoverage bias. Have your note cards out, have examples of these, watch the speed run videos. If you haven't checked this out, please go to the review page and check out on the review page the following. So, some people might even say it's a multi-stage. It's definitely clustering because you're going to the dorms and taking all of one dorm. It's not a good idea probably either because there's differences between the dorms, so you should probably stratify. I always hate putting multi-stage on there because there's always a way to debate, is it a multi-stage? But a key aspect of it is the clustering idea. And so if you want to go through these ideas again, I would check out these reviews right here with the challenge to Davey 504 at the end, where I go through all these ideas. Has anyone watched a speedrun video? This is basically a lecture where Brian doesn't do any jokes. He doesn't make any side conversation. It's a lecture where I'm just constantly going through the material, and they can be found here on the page. So if you want, there's other versions too right here. These are the older versions. You can see the sampling methods chapter right here. You want to see how long ago this is?
Put it on Facebook.
I made this video during the 2016 presidential election. This video was made 8 years ago. This is an 8-year-old video now, and The Simpsons did this. Oh, you'll have the hair. Which hair do I? Oh, the previous hair. Yeah, the hair right there, that Brian hair. So check out these videos. Check out the videos going over the test. If you're stuck on anything on the test, here's all the different test questions and full reviews of me doing test. You can see different hair length Brian's right there. Oh, this is right before, this is March before the pandemic, so I'm teaching from the studio. Oh man, that's our first thing. This is back in the day. This is back when I used to do from this screen right here. So wow, long ago, man. It was 40 or 14. I'm an old man. Next question, leaderboard first. Let's do this. Stellar Tiger, Inspired Urchin, Legend Gazelle, Glowing Macaw, and Focus Goat. Let's do this. What is the best way to know the difference between p hat and y bar versus p and mu? And I'm specifically talking about p hat versus p. How do they differ? You can use the other one too. But what's the difference between p hat and p? If you're confused by this question, p hat is for a what and p is for a what? P hat is for a what and p is for a what? Yeah, I'm not blocking right answers. I'm happy with that. They also appear on your phone too, I think, but I'm not blocking right answers. There's only one right answer. It's a tougher question. It's not the best question. I'd never put this on the test. Don't worry if you get it wrong. I had this question before and people usually get it wrong because it's a little confusing. What you need to know from this though, is you need to know what the notation is. And I know I've been advertising a lot right here, but I want to drop a video I just made and I want to show you how to know your notation, and I want to show you why this is the right answer. To know the notation, go to the office hours video right here. I got confused by p hat and not a p with a hat exactly. Check out this video right here where I go over the full formula sheet. So these are self-contained right here. I go over the full formula sheet in this video. Who's going to watch this video right here where if you look at the length of the segments, each of these segments is about 10 minutes or so on the portion of the formula sheet for each chapter. So you can see each chapter's portion of the formula sheet. You can just click and go right to it where I start to go over that part of the formula sheet and explain how to understand it. Savannah, what's your thoughts? I hope this helped out. A lot of people get confused by the formula sheet and the notation. So you can see I'm talking over here about p hat and q hat and what these things are. The different things right there where we have n is sample size, lowercase n, and x is number of successes. Loved it. Thank you, Savannah, right there. P hat is sample proportion and p is true proportion. So p would be the true proportion and p hat is the sample proportion right there. And you can see I've been highlighting stuff and showing an example right here. So I really hope it helps. This is a tougher chapter. And if you got that question wrong or just didn't understand it, don't worry, you're not in the minority. I go through each one of these notations and I even try to write an example problem where we know that we know from the UT registrar that 70% of students are in state. So 70% of students would be an example of what? Look, it's clearly marked for you. We know 70% of students are in state. So this known quantity, the proportion that is known, is what in notation. And it's marked all throughout here, it's P. Now we went out and talked to 200 students, which is our sample size, and 150, I should have marked the X right there, 150 were in state, leading to a sample proportion of 0.75. Did I go through and mark that a little bit more? The sample proportion of 0.75. And that I even showed over here on the curve, showing you how we can graph the z-score and show where that is at on the curve with the z-score. So I kind of do a full problem and mark all the notation. I really hope that helps. RotoWave, see you. Swing by, man. Say hey. Good seeing you, RotoWave, right there. Tougher question. P-hat and Y-bar come from sample sizes. That is true right there. These other ones are not wrong. It's just not the difference between P-hat, Y-bar, and P and mu. The difference between this group and this group is this is sample statistics, and these are population parameters. So it's that they come from sample sizes over on the left, which is the truth. They don't come from a population size. These come from population sizes. It is true that p-hat is categorical and y-bar is quantitative. That is true. It is true that p-hat is for proportions and y-bar is for means, but the difference between these two groups, once again, I wouldn't put this as a test question, so don't write this one down and study it. You're mainly just meant to know the notation right here. Review 2, Inspired Urchin, Stellar Tiger, Legend Gazelle, Glowing Macaw, Focused Goat. Next question. The central limit theorem is fundamental to statistics. Wait a minute, did I just say the answer? Yes, I did. If you were listening in, you know that the central limit theorem is fundamental to statistics because it states that the distribution will become more normal and tighter. It allows us to use the normal curve, i.e. empirical rule stuff. I'd write down the central limit theorem is fundamental to statistics because it can appear on the test. I want you to know that and not be shocked if you get a question that asks you this. It's not like I know what's on the test. The other things, a squared plus b squared equals c squared, is Pythagorean theorem. States over the long run, repeated trials will see the true probability. That is the law of large numbers. States that events less likely or more likely to occur. That is gambler's fallacy, or sometimes known as law of averages, which is a fallacy. This is a fallacy. That's this is law of large numbers, which is a chapter 10 concept, and this is other math outside statistics. But the central limit theorem is fundamental to statistics. It allows us to use the what curve. The central limit theorem, which states that the curve will become more normal and tighter. The central limit theorem is so fundamental because we can do calculations based on the what curve. That's why it's fundamental. It's like very important. It allows us to do it on the normal curve. That's why it's fundamental, because then we can do calculations. We need it. So it's a theorem. It's been proven that the normal curve will be obtained. Sorry, Mr. Peterson. You think normal curve's not there. It's there. Central limit theorem. Inspired Urchin, Stellar Tiger, Legend Gazelle, Focused Goat, Glowing Macaw. Next question, here we go. The conditions for the distribution of the sample proportion are what? So what are the conditions to do the distribution of the sample proportion? Now, the first two conditions are always the same. And if I appear, I'm usually not blocking a right answer. I try not. Wrong. So right now, you really only have two conditions you know at the end of this. When we say random is the first condition, that means we randomly select data. 10% means less than 10% of the population is sampled. And last, you need to pause and ask, are we doing categorical or quantitative? And so great job. Now here's the problem. What do you think people usually say is the third condition for the sampling distribution of the sample mean? When I ask, what is the third condition for the sampling distribution of the sample mean, what do people usually say? If I say, what is the third condition, or like random 10% and for sample mean, what do you think people usually say? Well, you have the right answer right there. That is the right answer. For the sample mean, it's large enough n. That's the right answer. But a lot of people just say success failure because it's the first thing you learn. So they're like, oh yeah, random 10% success failure, but it's large enough n. And we have some videos in that where I go into more depth. Check out the office hours. I even segmented it, I think, on the 1st of April. It's large enough n, which states that we need a large enough sample size, either 1, 25, 100, such that the distribution of the mean will be nearly normal, not the original data. So make sure to know that when it's categorical, these are the three conditions for the sampling distribution of the sample proportion. And when it's quantitative, these are the three conditions for the sampling distribution of the sample mean, because it's quantitative. Next question, or Inspired Urchin, Stellar Tiger, Legend Gazelle. Next question, let's do this. The large enough n states what? So you just heard me say some of it a moment ago. What would it be? Now be very careful. There's small notation differences right here, and I'll point out why it matters. And I even have a hint up at the top. I wrote it this way. So there's small differences right here. Catch the differences. What is the large enough n state? Large enough n condition state. It states we need a larger sample size, which is lowercase n, the less normal a distribution is. So when we have a more skewed distribution, n will need to be water. When we have a more skewed distribution, n needs to be water, which means it's less normal. So a highly skewed distribution, let's go to the central limit theorem applet, needs to be larger. So with this right here, the central limit theorem applet shows this for us. How large does n need to be if the data is normal? How large does n need to be? Like if I take two observations and take the mean, I want to know if the distribution of the mean will be normal. That's what it means if we meet the conditions. It only needs to be 1. So is 2 large enough, yes or no, that this distribution, if I do enough simulations, will look normal? Is this large enough? Is 2 large enough since n needs to be 1? Yeah. So because of that, the distribution is normal. But this distribution is skewed. So if it's skewed, how large does n need to be so that the resulting distribution of sample means will be normal? So now I'm doing sample means. Notice how every blue dot is the average of 2 black dots. See, that's the average right there. I'm going to move to where the average is at. It's right there. It would need to be 25. So is 2 large enough? Will 2 be large enough? And you can see the answer now. Will 2 be large enough such that the resulting distribution will be normal, i.e. the central limit theorem? What's up, Charlie? Good to see you here. More classic students. More points in the chat. So the answer is no, this is not large enough. But look at this. If we do the sample size of 25 and do 25 random observations and take their mean, the sampling distribution of the sample mean, if we do this repeatedly and get a lot of blue dots down there, which are sample means, the resulting distribution is normal, and that is the central limit theorem because 25 is large enough for skewed distributions. Hence why on this right here, I have 1, 25, 100. 1 is for normal, 2 is for skewed, and 100 is for very skewed. Leaderboard time, because we got 20 minutes. We have Inspired Urchin, Stellar Tiger, Legend Gazelle, Glowing Macan, Rockstar Bat. Next question. How do we check the 10% condition? What do we need to check with the 10% condition? Basically, it's part of it, Autumn. The central limit theorem is fundamental to statistics, and it states that the distribution will become more normal and tighter as n increases. And the large enough condition, large enough n, basically shows the central limit theorem is true, because if we have a very skewed distribution, it will become more normal. So it's like the large enough n is a way to confirm the central limit theorem has been met. That's the way I'd say it. The large enough n is a way to state that the central limit theorem has been met. A lot of people here marked the success failure condition. This is a fact. See if there's at least 10 successes, at least 10 failures, but that is known as the success failure condition for proportion data. And we need to see if the sample size is less than 10%. So if I sample 20,000 UTK students, did I meet or not meet the 10% condition? If I sample 20,000, the quiz. Oh, that's awesome. If my sample size is 20,000 UTK students and there's 35,000 UTK students total, did I meet or not meet the 10% condition? No, I did not meet it because I sampled more than 10%. I sampled more than 10%. The way to do this right here is to divide the numbers. And here I'll call it 30,000 because I can divide those numbers in my head. And that would be 66% was sampled. I've sampled too much. Charlie, let's do Charlie 1,000 point. Get some W's for Charlie right here. Charlie, another classic student. Good to see you. It's so funny. I tell people I remember names better when I see it because it's just I see Charlie in the chat. Classic student right there. Give some W's for Charlie. Charlie, thank you so much. Even answering the questions still, practicing some Stat 201. So right there, the 10% condition would not be met if you sampled 20,000 of the 30,000 UTK students because you sampled more than 10%, and that's a problem. We do have corrections for this in statistics due to finite and infinite populations. We don't cover that in 201, so you would technically need more advanced methods, just better calculations. So with our basic calculations, we would have to do something better. You can fix it. It'd be another topic in the class. Inspired Urchin, Stellar Tiger, Glowing Macaw, Legend Gazelle, Fabulous Dragon. Next question. How do we check the success failure condition? What would we do mathematically? I have to keep my stats knowledge up while that's awesome. What are you doing? Yeah, I love when people are promoting, especially like you need to have stats knowledge. It's very, very important for just working with data. And what jobs work with data? Name a job that doesn't. Someone try and name a job that doesn't work with data and I'll throw 1,000 points. I will come up with an example of how they work with data. If you can find a job that doesn't work with data, does anyone have any ideas? I will come up with a way that job works with data, especially if you want to get advancement in that job. Hopefully people are thinking, they're like, I can't think of anything that doesn't use data. A lawyer? Wait, a lawyer? Sorry, man, I'm throwing you 1,000 points. Just the way I said it. The way I said it, I feel like I got 30,000 points. A lawyer, no, I love it, because that's like, it's someone that works in the sewer. Would you want to go into a less dangerous or more dangerous sewer? Would you want to know how to be safe in a sewer? All that's data. When you see that something's happening in the sewer, you're taking in data as shoe shiner, that's a business. Any business. And I'm throwing another 1,000 points because I want to tell you, any business, whether you got a nail salon, whether you got a shoe shining business, you're taking in data. You got to know about your customers. A garbage man, well, you got to know what time people are putting out their garbages. I get emails from my garbage company if we don't put out our garbage, and they even send a picture that shows we weren't putting out our garbage because they don't want us to say that we didn't have our garbage down there and they didn't get it. So they're taking in data, who had their garbage out, who didn't have their garbage out. Garbage is a business. It's a big business. So there's so much data in the garbage business of like, what are people throwing away? Is it hazardous material? What time do they put their garbage cans out? Did we not meet it? Someone that is unemployed, they're constantly looking for employment. They're looking at all the sites figuring out. But I think everything requires data. So it's all data out there. I love it. I love it. I asked an impossible question. Show me something that doesn't use data. It's all data all the time. And so we see if N, P, and NQ are greater than or equal to 10. N is the sample size. P is the true proportion. Q, someone who is not looking, oh my gosh. So Savannah, I think we got to throw Savannah 1,000 points. Savannah outthought the example. Performers, they're self-employed. They're taking in data. How big was the crowd? Savannah has the answer. Someone who's not looking for a job. I like that answer because if you don't want to if you don't want to look for a job, you don't got to worry about data. Say, I don't want to. Then you start playing video games and then you're worrying about data again too, because video games are all data. So don't play video games, don't look for a job, don't make recipes because that's all data, it's all numbers, it's all quantitative, it's all categorical. So any service product needs data, all data, everything's data. And the better you are with data, the better you are at your job usually. So continuing on, Brian had a fun moment right there. Inspired Urchin, Stellar Tiger, Glowing Macaw, Legend Gazelle, Fabulous Dragon. Next question, let's do this. The success failure condition states which of the following? I'll tell you this much, it does not state that it needs to be binary. Kind of like I'm telling you that the success failure condition, almost like you should put that on a note card. Brian had a little fun, now he's way more serious. Almost like you should know what. The success failure condition does not say what. Almost a hint for the test. The success failure condition does not say what. What does it not say? So once again, I want to repeat this just to make sure people know it as we get closer to the test. The success failure condition definitely does not say what. It definitely, Joe has it right there. Your variable does not need to be binary. That is not part of it. I mean, it's kind of entailed in what we do, but that's not the condition. No worries, Joe. It says you need at least 10 successes, at least 10 expected failures via NP and NQ are at least 10. That's the condition. It's not that it has to be binary. Huge hint for the test. Next, leaderboards, Inspired Urchin, Stellar Tiger, Glowing Macaw, Legend Gazelle, Fabulous Dragon. Here we go. Probability of making a shot is 0.3. What is the complement? Nice and quick question. And I like this one too because it deals with P and Q. Because if P is 0.4, Q is 0.6. If P is 0.1, Q is 0.9. They're just one minus each other. If P is 0.02, Q is 0.98. If P is 0.5, Q is 0.5. P is 0.4, Q is 0.6. If P is 0.3, Q, which is its complement, is 0.7. So P and Q are complements when we get to chapter 13, and a lot of people know that. It's just a lot of people don't know P and Q, so it's just one minus. Exactly, that's what a complement is, and that's what P and Q are of each other, as with P hat and Q hat. So kind of reviewing chapter 13 with chapter 12 right there, to say P and Q are complements, one minus the other one, and great job, Marley, right there. Good comment right there. Just understand what I'm saying as I kind of talk over the question. Next, leaderboard, here we go. Inspired Urchin, Stellar Tiger, Glowing Macaw, Legend Gazelle, Fabulous Dragon. Here we go with the next question. The law of averages is a fallacy. The truth is what? And this is the law of large numbers. What is the truth? There are other truths on the screen, but we're looking for the truth of the law of large numbers. Because your friend flips a coin and they say it came out heads 100% of the time. Well, you flipped it one time. So what would we see right here? Some of these are just very, very wrong. When people think things average out, great job. Past events do not influence independent trials. Because the law of large numbers states we will see the true probability in the long run, just because someone flipped heads one time or two times doesn't mean that they're more likely to flip tails. That is very false. These are the addition rule. Two events that are disjoint can be easily added together. This is the multiplication rule. Two independent events, no worries, Bailey, can be multiplied together. But past events do not influence independent trials. It is the truth. The law of averages is the fallacy that if something occurs that's independent of something else, it'll be more likely for the other thing to occur and not occur. Leaderboard: Stellar Tiger, Inspired Urchin, Glowing Macaw, Fabulous Dragon, Legend Gazelle. Next question. Calculate p hat. We must meet what three conditions? Trick question. Anyone hear what I said? What is the formula for p hat? Type in the chat right now the formula for p hat. No, no, sir. No. It's a trick question. I know success failure is the third condition for the sampling distribution of the sample proportion to be normal, and that's why we do conditions. So what is the formula for p hat? Write the formula for p hat in the chat right now. Do you know it? Here's a question that you would solve p hat for. 2 of your 5 friends own cats. What was the sample proportion? So what is the formula for p hat? What is the formula for p hat? What is it's x over n. So 2 of your 5 friends own cats. What was the sample proportion of friends who owns cats? Own cats. 2 of your 5 friends own cats. What is the sample proportion of friends who own cats? So just solve that right now. 2 of your 5 friends own cats. 2 over 5, 40% or 0.40. What conditions did you check to find that? So imagine you haven't taken stats. What conditions did you check to find that? What conditions did you think through to find that, to find 40% of my friends own cats? None, there's no conditions. The conditions for the sampling distribution of the sample mean and the conditions for the sampling distribution of the sample proportion are to see if they are what? Why do we check conditions? The conditions are to do what? Why do we do conditions? Conditions are checked to see if what?
So we can see it, and here's what the probability would look.
Why do we do the conditions? To see if we can draw the normal distribution. The whole point, to calculate p hat, it's just x over n. So that's just a calculation. What are the conditions to calculate y bar? What conditions do we have to meet to calculate y bar? Your one friend gives you $5, the other friend gives you $10. How much did they give you on average? What are the conditions for y bar? What are the conditions for y bar? What are the conditions for y bar?
Sigma.
The conditions for y bar are none. You don't have to have conditions.
It took me probably
the conditions
semester to even be like, okay, what is the same?
Wow, I said that yesterday, how long it took me to like understand this completely. These conditions right here are to check to see if it's normal. To check to see if it's normal. That's why we have random 10% and large enough n condition, which is sample size. You do these to check to see if it's normal, the assumptions of the central limit theorem. So the conditions to calculate y bar are nothing. It's just the average of the sample data. Does that make sense? Y bar is the average of the sample data. Mu is the true mean of the population. So the conditions are used to see if the sampling distribution of the sample mean is normal. The conditions are used to see the sampling distribution of the sample proportion is normal. To calculate p hat and y bar, there are how many conditions? Like this is on the test. It's a tricky question. How many conditions are there to calculate p hat and to calculate y bar? There's no condition. You just find them. The conditions are to see if the distributions are normal. Don't good hints for the test. Let's go to the leaderboard. Stellar Tiger, Inspired Urchin, Glowing Macaw, Fabulous Dragon, Legend Gazelle. Next question. Let's do this. We know UT is 20% freshmen. We sample 200 students and 30 report being freshmen. What is P? You have to know what the true proportion is. So if you know the true proportion, this should be nice and easy. P stands for true proportion. P stands for true proportion. You will need a calculator for the last question. We have still some Kahoot shirts for the winners. I'm gonna try to grab some snacks too. If you swing by my office, if you're first, second, third, swing back for a Kahoot shirt or an Amazon or Starbucks gift card. Email me first, second, third, $20 Amazon or Starbucks gift card, first, second, or third. A lot of people put this. What is 0.15? A lot of people put this, 0.15. 0.15 is actually what here? It's this over this. So what is 0.15? It says what is P, but 0.15 is what? 0.15 is not P. 0.15 is P hat. P hat is X over N, and this is the amount of successes out of a sample size. The Kahoot kicked me. The code is right down here on the bottom. Sorry about that. Sorry about that. That is P hat because X over N is P hat. 20%, we know UT is 20% freshman, so that is P, the truth. We know it is 20% freshman. This is N, this is X, X over N is P hat. Next question, here we go. Leaderboard, Stellar Tiger, Inspired Urchin, Glowing Macaw, Fabulous Dragon, Jolly Boa. I like Jolly. UT is 20% juniors. From 80 students, 30% are juniors. Find the mean of the sampling distribution. Find the mean of the sampling distribution. Formula sheet, formula sheet, formula sheet. I'm going to say the answer in notation at 10 seconds. Probably a little heavy, so I'll say it now. Mu P hat equals mu. We are looking for mu P hat up here, and mu P hat equals mu. So it equals mu. I mean, mu P hat equals P. Wow. Mu P hat equals P. I said the second time I was like, what? Mu P hat equals P. It's this. So once again, the formula sheet, I can't state the formula sheet enough. When I say the mean of the sampling distribution, we are talking about this right here, mu P hat equals P. Does everyone see this? So how would you find the mean of the sampling distribution? The mean of the sampling distribution is sample proportion. What do you need to find it? This is the quantity we want to find. So what are we going to have to find this quantity? We have to find P. So let's go back to the problem and look at it. And we have to find P. So mu P hat equals P. Well, we just found P a second ago. This is P. So the answer is this. It's the true probability. It's the true proportion. Exactly. Is it starting, for people who've been working on this chapter a lot, is it starting to make sense that if you find P, you know the mean for the sampling distribution, which is the expected proportion. This is a tougher chapter, takes a lot of practice. And when you start to get it, it's just like it clicks and you can get these really quickly. Because it says, what is the mean of the sampling distribution? So we go look at our formula sheet, and this is the mean for the sampling distribution of sample proportion. It's equal to P, because we want this quantity. That's what the question asks for. So we have to know what P is. We go back, and it says UT is 20% juniors. That is the true proportion. This chapter takes practice. Good job, Savannah and Autumn right there. Tough chapter. Next, leaderboard, Stellar Tiger, Inspired Urchin, Glowing Macaw, Fabulous Dragon, Jolly Boa. Next question. We know UT is 20% freshmen. We sample 200 students, 30 report being freshmen. What is P hat? Remember the formula is X over N. You got this. The last one will be the standard deviation, so get ready to calculate it with P times Q over N square root. I'm not doing that one right now, but this is just what is P hat, which is the sample proportion, which is X over N. Have your formulas written down on flashcards, know them, and know how to interpret them. The sample proportion is, when I talk to a group of students like 200, the proportion as in X over N, X being the amount of successes there are out of total trials, N. And we have here 30 over 200, which is 0.15. Really good job. Owen Wilson, wow, right there. Good work. Basically, everyone getting it right. Great job. And we have the leaderboard and the last question. Oh my gosh, who's going to win? Oh no. Let's check it out. Last question. UT is 20% juniors. From 80 students, 30 are juniors. Find the standard deviation of the sampling distribution. P times Q over N square root. And if you've already got it, start telling students the notation in the chat. P times Q over N square root. What's P, what's Q, what's N? So the formula is the square root of P and Q over N. So you have to solve that. P times Q over N square root. It's not square root of N, it's 191. Now there's only two possible answers because P is 0.20, Q is 0.80. There's P and Q, and N is 80. The formula, type it here in the chat, would be the square root of 0.2 times 0.8 over 80. Good work. There it is, P times Q over N square root. And I highly suggest, even if you've seen me give the answers right here, type these into the calculator to see if you get them right, where you do P times Q over N square root. What? I did 30. P times Q over N square root. There we go, 0.045 when rounded. Really good work here, everybody. If you can tell, chapter 13, 14 are tougher ones. We kind of scratched the surface of them here a little bit. Watch the videos, practice problems, try writing your own practice problems because these are tough. You have to know the notation, you have to know how to solve them. And I will say this, the MyPearson, this is my last bit of advice before we look at the leaderboard. If you did the MyPearson got a 100, that's a good sign. But if the MyPearson, if you are getting, and it's all right, if you're getting 50s and 60s on MyPearson, remember, that's where you have help videos. That's where you can ask me to work it with you. That's where you can use your notes. The test is only going to be tougher than MyPearson in terms of you don't have the same resources. So what you want to be able to do, wait, what's cancel? Why would you use 80 instead of 30? 80 is X and 30 is X, and 80 is the sample size right here. So 80 is X and 30 is, oh my gosh, I can't speak. 80 is N and 30 is X. Does that make sense, Autumn, right there? 80 is N, the sample size, and 30 is X. 30 is the amount of successes out of the sample size of 80. So practice the problems, watch the videos, try writing out your own examples and ask those questions like Autumn just did right there. Let's check out the leaderboard. The winners are Stellar Tiger in first, Glowing Macaw, and also Inspired Urchin. Thank you so much, everybody right here. We're gonna do an event for students with Mario Kart coming up here. So I'm really excited. We'll do a little Star Wars outro. Bye for now, everyone, bye! We've almost got these new intros ready. We're almost there.
This has been going for like 20 hours. This ends now.